Alright, so any thoughts where we start with this one? How did you know it was special triangles? Exact values, remember the... Alright, so, yes, which triangle? 60-30. What's the sides?
One to that side, I think, I'm pretty sure. One, and then two, and then square root.
Yep, so hopefully you know that off the top of your head. Yep, so that might be worth, a mark. Tick. What's the next step? Someone else.
Right, the cos theta equals a over h.
Yep, so we have the adjacent and we have the hypotenuse, longest side, so we know it's cos. Theta equals adjacent over hypotenuse. We know cos 60, the adjacent is x and the hypotenuse is 13 centimeters. Using our special triangle, 1 over 2 is also cos 60. Does that make sense? So if cos 60 is 1 over 2, so we rearrange for x. So x is 6.5 centimeters. We draw the special triangle over the hypotenuse. Yep. So you should just have that. 2 ticks. Okay, next one. We need the unit circle. So we're going around 360, and then we're going around an extra 420 minus 360, 60. So we're again using this triangle, opposite over adjacent, which is? Yep. Okay, so that's it. Question?
Could it also be tan 30 just because 420 is also much more 30?
No.
What makes it 60 and not 30?
I think it's called the corresponding angle. That's why it's equal to tan 60. Does that make sense? Any other questions? So we're bringing in negatives. Some of you guys struggled with this. So we're going back 30 degrees. Okay? So, yep. But we have a negative 30. So there's a couple of ways of understanding this. You could use the all stations to central. Is it positive or negative? Positive. So imagine this is x and y. X is positive, and what's y? Okay? If it was over here, x and y are negative, so it becomes positive. I don't know, there's kind of lots of different ways of interpreting it. I hope one of those ways made sense to you. Otherwise, happy to help you guys individually.
So in the end, could we have just used negative 30? Why do you have to find 330 or something?
Because it might not be negative. Like if it was negative 120, it's not going to be negative.
Yeah.
Does that make sense?
Yeah.
Wouldn't that still be negative and quadrant?
Yeah. No.
Like anything on negative.
So cos negative 120, all stations to central. So it's meant to be negative, but the angle is negative, so it's actually positive.
Just cancel
You
it
need
out.
Trig instead of 120.
Wait, so you just cancel it out.
When you're in this one, right? It's negative 30, so it's a negative answer. When it's in here, it's negative 120, but its tan is positive, so it's meant to be negative, but it's already negative, so it becomes a positive. Does that make sense?
Yeah, like negative divided by negative.
Sine 225. So again, drawing the unit circle, it's going beyond 180, so we're in this quadrant. All stations to central. So this tells us only tan is positive here. So is it going to be a negative answer or positive? It's negative. Okay. So we've got 180. So 225 minus 180 to get this angle in here. 45. To get the smaller angle, to use the special triangle, okay? Because we don't know 225. You need the corresponding angle, or the supplementary angle, I can't remember what it's called. 45 degrees, because we know 45 degrees, or does anyone remember it? 1, 1, square root 2. Okay, so now we can find 225, but it's just a negative version of sine 45. Does that 5 ticks? Because you've got to get square root 2 off the bottom. Everyone remember how to do that? You times it by, this is called the conjugate.
That sounds like a place. That's a word.
I'll write it down. Conjugate. It's just to get the surd off the bottom, because mathematicians don't like surds on the bottom apparently. To use the sine rule, or sine A over A equals sine B. The first one, why?
It's because you don't have to do the long equation to switch sine B around.
Yep. So tip for the exam, use the one where the unknown is on the top of the fraction. So the side is on the top, so we're going to use that one. Okay, so then that's worth a mark, then you substitute in. So this is A and A. So 7 over sine 75. And B, x over sine 80. Okay. We then bring the sine 80 degrees to the other side. How do we do that? Yep, so we multiply both sides by sine 80 degrees. To your calculator. Gotta have units and 2 dp. Okay, 7.14 meters. Kind of like Pythagoras theorem. Do you remember that?
Yeah.
But there's this little extra bit at the end. It's the same letter at the end as the start. So if we know 3 sides, so it's cosine. Okay, we sub them all in. All right, so then we do 8 squared minus those divided by all of that equals cos, this is meant to be a negative. Oh wait, I'll just do this first. And then how do we get the cos to the other side? Because we want theta by itself. Cos inverse. So it's like, looks like that. So theta approximately equals So this question is all about getting the diagram, okay? So we have a 40-meter high building. She's gone south, and then she's gone east 80 meters, okay? When she's gone south, it's a right angle, yep, and we have an angle of elevation of 23 degrees. Okay, then she's gone east, also right angle, and now she's got the same height. Let's do the first triangle here. 23, we have 40 degrees, and let's get this bottom side, let's call it V. Okay? Now we've got V, so we have that side and that side, it's right angle, so we can use Pythagoras. The hypotenuse is W, so W squared is V squared plus AT squared. So the last triangle, W40X, again, opposite over adjacent.
Where is this